The Digital Equipment Corporation is supporting a wide range of projects in speech technology at the Universities of Wales and Dundee. At the University of Wales School of Psychology, researchers are investigating a number of applications for speech technology, developing strategies that will enhance human-computer interactions and result in usable and efficient systems. Contemporary technology is bringing the paperless office closer and closer to reality. Electronic messaging has replaced surface mail with great success. Notepads and diaries are being replaced by computerized alternatives. But despite the widespread adoption of electronic document processing, there are still certain tasks, such as proofreading and annotation, in which users show a strong preference for working with a hard copy. Research conducted at Cardiff has contrasted the different types of annotation methods. Results showed that people had a marked preference for using voice annotation in particular circumstances.
The first paragraph's too long-winded.
Voice can add a personal touch and convey extra information by means of paralinguistic cues such as intonation. Voice annotation is appropriate for short, simple messages and spontaneous comments.
I think a lot of this will need to be simplified.
In contrast, typed annotations are most useful for editing, conveying complex information, or adding spelling changes. Of course, both spoken and typed annotations can be added to the same document. Finally, it was found that spatial or positioning information is conveyed most efficiently with a mouse or by hand. It is hard to convey information of this type using speech. Overall, the research suggests that while speech allows a lot of information to be conveyed with ease and speed, a voice annotation facility should be used as a supplementary medium, enhancing rather than replacing other methods. Some applications have made use of synthesized speech for conveying instructions or system response, but these have not always been well accepted. One reason for this is that even if the computerized speech is highly intelligible, a mechanical voice has the potential to become irritating. This will affect people's response to the whole system. The DECtalk speech synthesizer can produce a wide range of synthetic voices which can be modified in many different ways. In this experimental trial, people are being asked to rate their reactions to different voice characteristics.
The seizure of the castle brought victory.
Statistical analysis of the results showed their responses were strongly influenced by two factors, described as listenability and assurance. Listenability relates to the aesthetic quality of the speech, and two parameters were found to contribute to this factor. The first, smoothness, involves attenuation of the high frequencies in the speech signal. As smoothness was increased, subjects rated the voices as being more listenable.
This is smoothness set low. This is smoothness set high.
The second determiner of listenability is richness or brilliance. Subjects preferred voices which were low in richness.
This is richness set high. This is richness set low.
Assurance, the other factor which influenced people's responses, is related to how calm and assured or urgent and panicky the voice sounds. People found voices with low average pitch more reassuring.
This has a high average pitch. This has a low average pitch.
Resonance, which is manipulated by the DECtalk parameter head size, is also important here. As head size is increased, subjects rated increased assurance.
This has a small head size. This has a large head size.
Results of this study will help in the design of a more listenable voice, which is less irritating to users. It also indicates how to suggest urgency or reassurance, which may be important qualities for specific applications. 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « 」 « At Dundee University, researchers are undertaking a number of complementary projects which aim to improve the lives of people who rely on computer technology in order to communicate. Synthesizers have proved to be indispensable communication aids for people with severe speech impairments. At the Micro Centre, a number of projects are aimed at making these communication aids more flexible and natural to use. The practicalities of using a synthesizer to communicate can severely disrupt the spontaneity and flow of human conversation. Often, people suffering severe speech impairments also have problems with manual dexterity, and so inputting text is a slow and tiresome business, creating long gaps between words and phrases. Using ideas and techniques from conversational analysis, a system has been designed called CHAT. This system models the opening and closing stages of a conversation and supports a variety of dialogue styles.
Hello, Ian. How are you today?
Within this framework, a number of complementary systems are under development. PAL works by allowing the user quick access to words and phrases with the minimum of typing. On pressing the key for the first letter of a word, the user is provided with a list of possible words. If one of these predictions is correct, the user can select it. PAL adapts to the user's own vocabulary, preferentially selecting frequently used words and building a personalized dictionary. Floor Grabber is a communication system which gives the disabled user quick access to narrative texts. The system assists users in navigating through pre-stored texts, allowing them to take the floor in a conversation or discussion. The narrative texts are composed prior to the discussion or debate and are then recalled as they are required. Human speech contains variations in intonation and stress, which can serve to communicate the emotional state of the speaker. However, people who rely on synthesizers are restricted to a single neutral emotional style for all their spoken communication. Hamlet stands for Helpful Automated Machine for Language and Emotional Talk, and is intended to enhance the quality of speech available to speech-impaired users. Hamlet is a rule-based system that modifies DECtalk's voice and the duration and pitch of a phrase to simulate sadness.
There are 10 people standing in the room.
Happiness.
There are 10 people standing in the room.
Anger.
There are 10 people standing in the room.
And a range of other emotions. Research is continuing to improve the realism of the Hamlet voices and increase the range of emotions simulated by the system. The ECHO project is built on the premise that the problems faced by a disabled person in an ordinary environment are paralleled by those faced by an able-bodied person in an extraordinary environment, such as in a jet fighter cockpit. The ECHO project aims to develop an accessible office workstation for disabled users. The workstation uses an extremely wide range of input devices, including speech technology, eye trackers, and data gloves, so that the system will be adaptable to a wide range of physical disabilities. The many projects currently under development at Dundee University have already greatly improved communication for some disabled people, and continuing research at the Micro Centre promises further enhancements. As well as research into speech output, the science of speech technology is also concerned with the investigation of speech input. Researchers at the University of Wales are investigating the use of speech recognisers and the importance of dialogue design. Most speech recognisers work by matching the spoken input with pre-stored templates of the user's utterances. If the spoken word is matched with the wrong template, as does sometimes occur, it will result in a misrecognition. Repeated misrecognitions can produce extremely negative evaluations of speech systems and an overwhelming reluctance to use them. Scientists at the University of Wales have evaluated a number of techniques of effective error recovery. One approach involves the temporary removal of the templates which have caused the misrecognition. For example, the machine may have templates to recognize the words this, his, list, and is.
This.
The user attempts to enter the word this,
This.
and the machine recognizes the input as his.
No.
The machine then temporarily deletes the template for his. This increases the probability of the word this being correctly recognized at the second attempt.
This. Correct.
When most speech recognizers receive input, they produce a hierarchy of possible recognitions ranked according to the closeness with which each matches the input. An alternative method of repairing the dialogue after a misrecognition makes use of this by offering the user the next best choice. This technique proved to be the most efficient and has the advantage of being easy to implement as it does not involve template removal. No confirmation command is necessary, and the user does not have to repeat the input. In many systems, feedback takes the form of natural speech which has been digitized. The messages are created by concatenating or linking together a series of recordings of words and phrases. In normal speech, stressed segments are equally spaced in time, and pronunciation and intonation depend strongly on context. Consequently, the concatenation process disrupts natural intonation and rhythm, and can result in confusing sounding messages which are hard to remember.
This is a recording of concatenated speech.
A technique known as perceptual centering has been developed by researchers to help overcome this difficulty. It involves finding the psychological moment when the listener perceives that a word has been spoken. Using this as a reference, the gaps between the words are adjusted and the concatenated message has a much more natural delivery.
This is a recording of concatenated speech.
When the findings from research projects are applied to speech system design, powerful and usable systems can be built. This simulation of a potential application shows how the various technologies can be combined to form an integrated and usable system.
Destination: Cardiff Airport. Standard route.
Confirmed.
Dial 4 5 1 2 3 6 7.
Hello.
Hi, this is Jane. I'm catching the plane just after 9, so I should be there about push to 11.
Fine, I'll pick you up from the airport.
Okay, see you then.
Fine, bye.
Request traffic status.
Delays on M5, junctions 11 to 13, enter.
Delays on M5.
Request alternative route.
Route calculated.
Request instructions.
Turn left at A48. Turn right on B735.
The Digital Equipment Corporation and the Universities of Wales and Dundee are continuing with collaborative projects in speech technology. This research is making widespread implementation of speech systems a practical reality.